So today we have this one of my favorite question. The question says that if square root of a plus square root of b is equals to square root of 2057, what can be the possible values of a and b? Here this a is an integer, b is an integer, and 2057 is an integer. So let us see that. So this is a very beautiful because there are perfect steps to solve this kind of problem. Instead of 2057, if any other number is like 2009 is present, or smaller like 48 is present, or some medium range like 363 is present, any number is present, you can solve that. So there's a perfect steps, and at last we will see the general equation which we will generate as we will solve this equation. Yes, so let us see that. Yes. Now look over here, that root of a plus root of b is equals to 2057. So what we will do in our first step is that we will square this both the sides. So squaring both the sides, so square root of a plus square root of b the whole square, and that would be equals to square root of 2057 the whole square. Yes. Now over here, square root and under root get cancelled out, so square and under root got cancelled, so what left is 2057. Not 75, 57. Yes. Now the LHS, root of a the whole square means a, plus root of b the whole square means b, plus 2 times under root a under root b. Yes, now the main game starts from here. Here we can see a is an integer, b is an integer, and here 2057 is an integer. But this part over here is an irrational part. As under root is present, it's an irrational part. But what we know that if anything is added or subtracted from irrational, the resulting answer is also irrational. But here, with irrational, some integers are added, which are a and b respectively, and we are getting an answer is a perfect integer. So what this indicates that this irrational part must be a rational. This is becoming irrational just because of this under root sign. So, but here a and b are variable present over here. So this part must be rational, then and then only integer plus rational, integer rational. We can just say rational because rational is a bigger branch than irrational. All here it's rational, here it's rational, here it's a rational number. So this should also be a rational number, then and then only this condition that rational plus rational is equals to rational will satisfy. So why this becomes a rational? Because only the thing which makes this irrational is the under root sign, and we have to remove that because it can remove because a and b are variables. So we will generate conditions for a and b such that it will form a perfect square which would cancel out this under root. Now just writing that under root ab must be a rational thing. It should be rational. Yes. Now under root ab must be rational. So what can be conditions for a and b are there? These are solved like this way only. I will provide you probably 2 to 3 questions in which we will generate conditions and solve the questions very easy. So a and b. So we will consider something a like a variable p multiplied with something square, and b the same variable p and square of something like n square. So when I will multiply this both, so what can be the result? Pm square into pn square. So it would become p square, m square, n square, and that can be written as pm n the whole square. So an under root would come, so under root and this cancel out. So this is the specific condition which is given to solve this question. You have to remember this condition, that to form under root ab as a rational, ab the conditions for a and b are there, a common coefficient, a variable we can say, and multiplied with a square coefficients that can be different. So these are the values of a and b. So values of a and b we will put in our original question, which was under root a plus under root b is equals to under root 2057. So let us put that. So under root a would become a longer one, p into m square, plus under root b would become p into n square, and that is equals to under root 2057. Yes. Now I can say this m square is an under root, so it can come out as a single m, and under root p as it is because p is not a square, plus here n has come out and under root p as it is, and that is equals to under root 2057. Now look over here, under root p can be taken common, so I will take under root p common, let it be clear. Yes. Now under root p taken common, so what remains inside bracket is m plus n, and that is equals to under root 2057. Now think which thing in this whole question has been left alone. Yes, this under root a plus b. Under root a and b has been done, but this under root 2057, this was left. Now this number, whenever this type of question will come, this 2057 or any other number is there, it will have a special property. First of all, we will just prime factorize this 2057 and then I will tell what is the property 2057. So let us check its divisibility, from which table it will get divisible. So look over here, it's 2057. So it will not come in the table of 2 because 7 is there. 2 plus 0, 2 plus 5, 7 plus 7, 14. So not from the table of 3. Neither 5, neither 4, neither 8, neither 9, neither 7. But yes, it will go with the table of 11. So with the table of 11, it will go like 20. So 1, it will go 11, 95. So 8, 88. So 77 means 7. Yes, from the table of 11, 187. Again, this will go with the table of 11 as 1 and 17. And I can see 17 is an odd prime number. So 17 will go with 17. So factors of 2057 are 11 into 11 into 17. So instead of 2057, I will write that value. So under root p into m plus n as it is, and that is equals to, instead of 2057, I will write 11 into 11 into 17. Now look over here, 11 into 11 into 17, this 11 is not, 11 into 11 is 11 square, and that can come out as a single 11, and under root 17 as it is, and that is equals to under root p into m plus n. Yes, now the special property of this number is that you can see over here, a square multiplied with a normal number, 11 square with 17, and if 2009 would be there, it has special. Let us prime factor out this one, because this was another question I saw this kind of. So here I can observe is that it will go with the table of 7. Yes, from the table of 7 it will go like 287, and from the table of 7 it will go like 41, and from 41 it will go 1 times. So again you can see 7 square and 41 means what, whenever this LHS, not LHS, RHS, the number is present, it would be most of the time in this form, a square multiplied with a normal number, so that the normal number would be in the root and the square one would come out. Now I can say it's under root p into m plus n, that is equals to 11 into root 17. So now I can compare this irrational part with this irrational part and this rational with this rational part. So what I can observe is that under root p is equals to under root 17 and m plus n is equals to 11. Now if under root p is equals to under root 17, I obtain that my p would be equals to 17. This under root cancels, so p is equals to 17. Yes, the value of p is equals to 17, and m plus n is equals to 11. So now p has the definite value that is equals to 17, and m plus n is equals to 11. Now m plus n is equals to 11, there would be something, many values which could satisfy this equation, that m plus n is equals to 11, m over here, n over here. If m values is equals to 0, then n would become 11. If value of m is equals to 1, then it's equals to 10. If it's equals to 2, it's equals to 9. If it's equals to 3, if it's equals to 8. This will go on till m becomes 11 and n becomes 0. And in between there are 4, 5, 6, 7, 8, 9, 10. So we can see the values of m are total 12 values for m, and n has a total of 12 values. So 12 values for both. So as m and n has 12 values respectively, and the value of p is equals to 17, that's fixed, and we have to find the solve this equation for the value a and b, and a and b we have the terms in of p and m. So let us find the value of a and b. So I have made a column over here that a is equals to pm square and b is equals to pn square. Now first of all, taking m is equals to 0, so 0 into p means 0 only, and the value of b is pn square. So as m is equals to 0, n was equals to 11. So 11 square into p. So as we have seen, 11 square into 17 is nothing but 2057. P was having a value 17. So it would become 2057. Then we have the value of m is equals to 1. So 1 into p, that's equals to 1 into 17, that's equals to 17 only. And value of b would become now 10. Instead, n value has now become 10. So 10 into 10 square, that is 100, into 17, that would become 1700. So 1700, now the value has become, yes, so 1700, and value of a was just 17. So like this way the values won't go on. We have to put the value of p is equals to 17 fixed and value of m as 0, 1, 2, 3, 4, and similarly according to this we have to put the value of n and we will generate the values of a and b. They are fixed, but there are many that are only 12 values are fixed for a and b. So that was the perfect steps. So also without these steps, whenever you see this kind of problem, you can directly have that my a was something like p under root, as we have considered in this case, let it be like this way, m under root p, and my b was n under root p, and that is equals to under root something like z, and that z would always factor out something like this way, s square t means some square multiplied with integer. So then we can compare this under root with the under root in the this part as we have compared in this case, and m plus n with the rational part. And for m plus n is equals to 11, we can generate this kind of table for values of m and n, and the value of p would be fixed, and from there we can generate the values of a and b. So that was the perfect steps to solve this kind of problem. So if you found this problem interesting, do subscribe to the channel and admit that you are unable to solve this interesting problem by giving a like to the video.